Parit Raja already solved the IC solution, where the first step is actually you find the homogeneous solutions. Find the homogeneous solution, where if this is step 1A, find the homogeneous solution. Step 1. Step 1, you find the homogeneous solution. And then in finding the homogeneous solution, you need to find in the step 1A, you need to find the eigenvalue. Right? You need to find the eigenvalue. Okay? And the eigenvalue, you have successfully found it. I repeat one more time. And successfully found your eigenvalue, which is actually to find eigenvalue, you let determinant of your A minus, when you find eigenvalue, you solve your determinant of A minus lambda I equal to 0. So you have negative 5 minus a lambda, negative 2, 0 minus lambda equal to 0. Okay, solving this one, you obtain your slowly negative 5 minus lambda, and then this is 0 minus lambda, so minus lambda. Okay, here be careful, you minus product of this one. So negative 2 times 2, this is positive 4. Positive 4. Then you expand it slowly. Negative 5 times lambda, you will have this is positive 5 lambda. So negative lambda plus, multiply negative lambda, so plus lambda squared minus 4 equal to 0. Okay, and then you can either you factor it or you can use your scientific calculator to obtain the eigenvalue quickly.
Total is positive 4.
So that's why when you do it, make sure you do it carefully, because once you get negative 4, later on your eigenvalue will be wrong, and the rest will be gone. Okay, and then here lambda plus 1, so lambda plus 4 equal to 0. So lambda we have lambda 1 equal to negative 1, lambda 2 equal to negative 4. This is a step 1A, finding the eigenvalue. Okay, after you get the eigenvalue, step 2, you find the
Doktor,
yes.
Doktor, bukannya sepatutnya lambda tu dia terbalik ke?
No problem. Okay. Normally if you put this is lambda 1, lambda 2, later on your V1, V2, it will be different, and it doesn't matter. But to make the answer consistent, I will normally say this one you want lambda 1, this is lambda 2. But if you exchange it, also doesn't matter. Okay. So if you want consistent, you take the lambda 1, the smaller value, lambda 2, a bigger value. So lambda 1 is negative 4. Then you find the V1. You find V1 from the system A minus lambda 1 I V1 equal to 0. Okay. So I repeat, put in back the A just now you have negative 5. From here you change to round, bracket, plug in the lambda 1, which is negative 4. So you have negative 5 minus a lambda, so minus negative 4. Okay, this is 2, this is negative 2, and then you got negative, lambda is negative 4. equal v1, let it equal to xy equal to 0. So you have here negative 5 plus 4, so negative 1, so this negative 2, 2, so this is positive 4, xy equal to 0. Okay, for those who are difficult to see whether these two rows are equivalent, you may just take up any rows. Okay, but in this case, you see if second row here you divide by 2, in the row 2 you divide by 2, if you put back to row 2, there's no changes on row 1. So negative 2 you divide by 2, you have negative 1, 4 divided by 2 is 2. Okay, but sometimes if the number is floating point, it's difficult to see whether they are same, then you just take up any row. And normally for homogeneous system, two equations will always reduce to only one equation. So in this case, you can just take up any row if you face difficulty to see whether they can reduce to the same row. Okay, and then okay, now you can see row 2 is actually equivalent to row 1. That's why I said if you face difficulty to reduce it, then just pick up any row only. Once okay, you have negative x plus 2y equal to 0. So means the x equal to 2y. Then you will let y equal to s. Let the y equal to s. Okay. Let y equal to s. Once x equal to 2s. So you have the xy. X is 2s, y is 1s. Factor out the s. Okay, by letting s equal to 1, you get your v1. Letting s equal to 1, then you get the first eigenvector v1, which is 2, 1. Okay, as I said, okay, if you put the lambda 4 is negative, if you put, let's say, lambda, okay, negative 4 is a lambda 2, then you only exchange, okay, so this one will be your v2. So mean your v2, you multiply by v, so it doesn't matter. Because A, B later on, after substitute initial condition, you get, okay, you will get the same, the last answer must be the same. So this is step 1b, you obtain the first eigenvector v1. Later on, step 1c, you find the v2, right? Find v2, okay, by solving your A minus lambda I v2 equal to 0. So similar ways, okay, you solve it like this one. Now you change, okay, you change your lambda 1 to negative 1. Okay, you just change it to negative 1. Negative 5 minus negative 1. And this is 2, this is negative 2, this is minus lambda, so negative 1, then xy equal to 0. So simplify it, negative 5 plus 1, we have negative 4, so this is negative 2, 2, negative and negative, so this is 1, y equal to 0. Again, so you can see if first row, I divide by 2, put back to first row. So I get negative 2, 2, negative 2, so 2 divided by 2 to get 1. So this is 1. This is 1. xy equal to 0. So now you can see that row 1 equivalent to row 2. Once you can mean two equations reduce to only one equation, so you will have infinite many solutions. Then you just reduce only one equation, which is negative 2x plus y equal to 0 or y equal to 2x. Okay, so in this case, y equal to 2x, we'll let the parameter, okay, the variable at the right hand side equal to s. So x equal to s, so y equal to 2s. So put that the vector xy, x is 1 time of s, put up s outside, y is 2s. Okay, why we say infinite many solution? Because s can be any value. We just take one of the solution where s equal to 1, turns the v1, which is, sorry, this is v2, which is 1 and 2. So after obtains your lambda 1, lambda 2, v1, v2, so this solution now we label as IC because we still have the IP, because this is a non-homogeneous system. So your IC is A v1 exponent lambda 1 t. So this is a case, the first the eigenvalue is you have a real and different eigenvalue. So this is the first case, and this is not repeated eigenvalue. So the easy A v1 exponent lambda 1 t plus b v2 exponent lambda 2 t. So v1 just now is it 2 1 exponent negative 4 t plus a b v2 is 1 2 exponent negative t. Now this is a particular solution already. So you can see from here, okay, lambda 1 is negative 1, lambda 2 is negative 4. Doesn't matter, okay, you change the positions. It obtains a IC already. Now we are going to determine the IP. As I said, choose IP based on vector G. Vector G in this case, okay, this is our vector G. This one is G. Vector G is constant. So choose the IP, a constant vector 2. Okay, second step. Step 2. Okay, find your IP. Because G is 140, then I will choose IP same form, mean constant. Okay, this is constant vector, so I choose constant vector. Okay, A, B already in the IC, so I use C and D. After you choose IP, CD constant vector, okay, this one constant time exponential, so it's exponential term actually. This is constant time exponential, so this is exponential term. This is constant, so it is not clear. Not clear, because when you expand, this is 2a exponent negative 4t plus t. 1 time exponent negative t. Because your IC is actually you have I1, I2, C in complementary function. Your I1 is exponent negative 4t into a exponent negative 4t plus b exponent negative t. I2, C is a exponent negative 4t plus 2b exponent negative t. This one is constant, so totally not clash. If not clash, then you just differentiate it. So differentiate constant, you get 0 vector. Okay, refer back the question. This is a system. Left side is di1 dt, di2 dt, where we denote as capital I prime. Matrix A is negative 5, 2, negative 2, 0, A. Okay, the vector I consists of element I1, I2 plus G. So you have your system is actually I prime equal to AI plus G. So plug in I prime P into your I prime. So left side you have 0 vector. Okay, vector A is negative 5, 2, negative 2, 0. Okay, we already assume I is a constant vector C and D. So it's C and D. Okay. Vector G is 140. So I'm going to okay. So now okay, you expand back this one in equation form because we are going to determine C and D. So when you expand back, negative 5C plus 2D equal to negative 100. Pause here. This is 2 by 2 matrix. This is 2 by 1. Okay. 2 equal to 2 here means the number of column in the first matrix okay, equal to number of row in the second matrix. So these two matrices can be so these two matrices can be multiplied and the result is actually 2 by 1. Then you got a vector, 2 rows, okay, 1 column. So yeah. So how we get the 2 row and 1 column? Negative 5 times C plus 2 times D. So second row, we have negative 2C okay, plus 0D. Okay, this constant vector I bring to the other side, that's why you have negative. So if you open back, say, the vector, so you have actually negative 5C plus 2D equal to negative 100, negative 2C, okay, 2C plus 0D equal to negative 40. You can solve it manually, but I will encourage you directly use your scientific calculator to obtain the root quickly. In the C and D quickly. We go to the equation mode scale. This is solving two simultaneous equation. 1. This model you can solve up to 4 simultaneous equations. So you got 2 simultaneous equations. Click 2, and then key in the coefficient. You have negative 5, 2, negative 100, negative 2, 0, negative 40, negative 40. So you get the x is actually the C here, 20, D is 0. So it obtains the C is 20, D is 0. So plug in C and D, that's why you have the IP is actually 20, 0. Yes. Yes.
Kenapa 100 tu jadi negatif ni? Dengan 40 tu?
Dia nak jadikan dia persamaan serentak kan? Ini dekat dia bahagian yang sama. Dia nak jadikan dia persamaan serentak ada AX sama dengan vektor B kan? Constant. Constant ni dia dekat bahagian yang sama. So kena bawa dia ke sebelah kanan lah. Kalau ni maintain dekat sebelah kiri, ini constant vector kan? So kena bawa ke sebelah kanan jadi tolak. So this side, yang ni kosong.
Okay, thank you.
Dia actually you collect yang ni, you collect this one and this one together. Sebab left side, I prime you get 0 vector. So you collect 0 vector and this one to the same side, so you get negative 100, negative 40. Because your A times I you maintain in, let's say A times I in, here we put this is the left side, so ini bawa ke the other side, collect dengan ni, dapat tolak 100, tolak 40.
Okay. Thank you.
And then I will encourage you directly, make sure you arrange correctly. Then you directly use your calculator to get the C and D quickly. Okay, after you get C and D, after you get your C and D, so you found your IP. This is the second step. Now step 3, your general solution. General solution will be I is a IC plus a IP. IC just now you have A 21 exponent negative 4t plus t 12 exponent negative t. Your IP is 20 0. 21. So this is a general solution, and the equation is actually the non-homogeneous system. Under this equation, you just directly solve it. Don't bother about the derivation of the non-homogeneous system or homogeneous system. Here, at time t equal to 0, I1 is 0, I2 is 0, find I1 and I2 means you have to plug in the initial condition. Okay, when you plug in initial condition, don't plug in into IC only. If you plug into IC, you can find A and B too, but it's wrong because you still have, because this ODE is non-homogeneous system, so you cannot plug in into IC. You have to plug in into the general solution. Because the purpose of initial condition is actually to solve A and B, but don't plug in your T here. Don't plug in when T 0, I1 0, I2 0 into here. Don't. This one you can plug into here provided your equation is only homogeneous system. Because if homogeneous system only, IC here is your general solution. But now you have the vector G. So this general solution for homogeneous system is only the IC, complementary function for the non-homogeneous system. Then your initial condition have to plug in into general solution. So remember, to get the particular solution, you must plug in the initial condition into general solution. Okay, for particular solution, takes notes. You must insert your IC initial condition means T equal to 0, I1 equal to 0, I2 equal to 0 into general solution. Mostly, some students will like to plug in into IC, easy, shorter. You don't have this term, shorter. Also can obtain A and B, but it's wrong. So remember, please take notes. Initial condition can only be plugged in into general solution. So now we plug in into general solution, because this one is actually your I1, I2. So 0, 0. So when T0 exponent 0 is 0, so you have A, this is 2, 1, B, 1, 2, because exponent 0 is 1, so plus 20, 0. Okay, now again, make it become your two simultaneous linear equation. Again, actually this like just now, because our left side here, this is 0 vector, this is 20, this is constant vector 20, 0. So make it into the linear equation form. You should have 2a plus b. It will expand it slowly. Like here, 2a plus b plus 20. Second row, 0 equal to a plus 2b plus 0. So make it become equation form. This is negative 20. This is a plus 2b equal to 0. So here 2a plus b, this one bring to the other side, so minus 20a plus 2b, a plus 2b equal to 0. Okay, use your scientific calculator again to solve it quickly. Okay, now is 2, 1, negative 20, 1, 2, 0. So you get the a is actually the x, a is negative 40 over 3, b is the y 20 over 3. So plug in a and b into your general solution, you obtain the particular solution. So now your particular solution. There's I1, I2. Yeah, a, right? A is negative 40 over 3. This will be 1. So this is A, this is B1, exponent negative, lambda 1 is negative 4t, B is 20 over 3, plus 20 over 3. So your V2 is 1, 2, exponent negative t, okay, plus CD. CD, just now what is the value? CD is 20, 0. Okay. Or you may expand. I1 will be the first row, negative 40 over 3 times 2. So negative 80 over 3, exponent negative 40. Okay, 20 over 3 times 1. So plus 20 over 3, exponent negative t plus 20. This is I1. I2, we have here negative 40 over 3 times 1. So negative 40 over 3, exponent negative 40. So okay, 20 over 3 times 2. So plus 40. Okay, this one, if your eigenvalue, you have the eigenvalue equal to 0. Okay, for example, okay, this is a example. Question 6. Question 6. The eigenvalue for here is 0. So you have, and this V1, you have 1 and 1. So you have exponent 0t. Exponent 0t. Okay, this is look like 3 equations, but the third equation is a linear equation. So you just solve the first 2. You just solve these 2 equations first. You have di1 dt, di2 dt. Your matrix A is negative 3, 2, 3, 2, 3, 2, negative 3, 2. So you have I1, I2 plus factor G is half, half. You can look at question 6. Question 6. Okay, you can ignore the application. Just solve the equation. Here, even though 3 variable, but the non-homogeneous system is come from the first 2 equations. Once you solve I1, I2, then you can find the I3. So in this case, also your vector G, this one vector G is half, half. Okay, and from the answer here, the IC here, okay, or you put H is stand for homogeneous, or you put the C stand for complementary function, same thing. So from here, obtains okay, the first eigenvalue is 0, the second is negative 3. So that's why exponent 0t is 1. That's why you did this one, you can write it. So it's A11 and G is a constant. Then you choose your I, okay. IP is C and D. C and D. Because you choose IP based on your vector G. Vector G is half and half. So you choose IP C and D. Okay, after you choose C and D, I said you have to check the IP whether, well, this one is IC. You have to check whether the IP clash with IC. So in this case, clash. You see, CD, constant vector. This one A prime 1, 1 also constant vector. So this case, clash. So if clash, CD here you have to multiply by D. Okay, so you see the IP solution. Here, multiply by